Hey guys, Matthew here. In this video we're going to look at the Boolean tools, which is an application of split and trim that's automated by the computer. So in this video we'll look specifically at 2D to start getting some of the concepts down, and then we'll look at the 3D ones in another video of their own. So, because there's a whole bunch of different tools. So to start with, I'm going to draw a square. And as we talked about, the square is closed. And it has an inside and it has an outside. And I'm going to copy this across 5 units and then move it up 5 units. There we go, cool. So I've got this kind of pattern. And now I'm going to copy this a bunch of times. So the first one will be 20 units, then 40, then 60, then 80. Okay. So we've got a whole bunch of them. Now, what's important to realize is if I have a point, the point can have a whole series of different relationships to the inside and outside of these two curves. So I have a point here, and if I move it anywhere, it's outside both of these. Okay? If I move it in here, well, it's still outside this curve because the inside is here. But it's inside this curve. So it's inside one and not the other. The relationship's true for the other curve, so this is inside this one and outside this one. And then there's also a set of points that's inside both. So what if I wanted the curve that only contained points inside both of them? Well, let's do that. So knowing the only commands we know are split and trim that would begin to do this, we can explode these out and then start to trim away the things we don't want. So we know we want these 4 lines to be involved in this process, and we can just trim this away like so and join it. And now we have the intersection between this curve and this curve. So this is the curve that contains every point that was inside both of the curves previously. So that one's pretty obvious. There's also the capacity to perhaps get any point that's inside either this one or is inside this one, which again would simply be trimming away the things in the middle. Join. So this is called the union of the two curves. This one's called the intersection. I can also change this up a bit and say, well, what happens if I wanted all the points inside this curve that are not also inside this curve? Which would be all the points in this L shape here. And I would do that by just selecting both of them and, of course, trimming the things I don't want away. And then I can just join that back up, and I have an L. So this is like this curve minus this other curve. And I could do the opposite, right? I could subtract the other from the first. And I could get that shape. And this is another similar kind of process. So these are called Boolean differences. So it's quite clear that the order matters, right? So A minus B, for example, or A difference B, gives me a different result to B difference A. And these are the two different results. So the order does matter. This is a union, and this is an intersection. So there's one last one which you should probably memorize, and that's called split. So a Boolean split. And all that does is it effectively takes these 3 and returns all of them as separate objects. So if I said, okay, I want to split this into as many constituent parts as I can, such that each of those constituent parts are closed curves, then you would explode the whole thing out and then start splitting like crazy, right? So anything you can split, you will split. So I've chosen rectangles for a reason because it's quite easy to figure out what's what. So here we go. I would just join these. Join these and get a rectangle to replace the missing closed curve here. And I've got a new type of Boolean. So this is the set, really. So we've got Boolean Split, which will break it into as many closed curves as it can. Boolean intersection, which will return the intersection of two curves. Boolean union, which will return the whole set, and Boolean differences, in which the order does very much matter. So that's the whole set. So this will be far more useful in 3D, but in 2D there's a cool command called curve Bullion. So if I make a whole bunch of cool curves, like super awesome curves, right? The best curves you've ever seen. Curves for days. Like so, and I've got a whole bunch of them. Well, these kind of operations of like what the union of all of them are, or exactly what is the intersection, is a bit more vague. And it requires a lot of work to start visually figuring it out. And let's do a couple that aren't, what you would kind of expect. So I've got a couple of open ones and a couple of closed ones. Yeah, sweet, cool. So this is my amorphous blob. So if I select all those lines, say, well, maybe I want this bit here. So that's a bit more difficult. I have to split a whole bunch of curves, or maybe I want these three quadrants here. Well, this is actually quite difficult to start doing, and it's going to be very, very time consuming. But if you use the command curve Boolean, CURVE BOOLEAN, I can just select those three quadrants and press enter. I can move it along, and I now have that. You can also click on the outside after typing in the right command, and it'll give you the biggest closed curve possible around all the curves selected, and that's that. So now I have the outline of that object, and I can choose specific things. If I've already got something selected, so say I've got my three things selected here, and then I select on the outside, it'll select the inverse of that. So it'll unselect those parts. So now I've got those three quadrants with the outline, and this is just the outline. So if I select outside, it actually just inverts the selection. So I get this curve back because it's a boundary of this, but it's like the thing that I'm getting out of the curve Boolean is this area here, right? This is the closed kind of shape that I'm looking at. In this instance, it's everything, and in this instance, it's this. So this minus this is, well, this, in that sense. A little bit confusing, but have a play around with it, and it should be quite easy and quite useful when you start getting into the drawing stage. And I'll see you in the next video, and we'll talk about 3D.